OSG solutions for electric vehicles. This video's topic is hubs. A hub on a vehicle is the central part of a wheel, which rotates on or with the axle. The spokes meet at the hub. When machining a hub, both the outer and inner parts require both drilling and threading operations. These are generally done on smaller machines, as the application requires low thrust. Listed here are some of the common thread sizes for hubs. For the drilling operation of hubs, OSG supplies two options depending on coolant capabilities. For non-coolant through, OSG supplies a special A drill, an AD with R-gash. This is a high-performance carbide drill. Sizes are made based on the specific hub application needs. For coolant through, OSG supplies its standard ADO 3D. It should be noted that machines for hubs tend to be non-coolant through and on the smaller side, as the drilling depth is short. Due to the nature of the hub and the available space in the small machines, low thrust force is a requirement, as the workpiece holding is not the most secure. Low work hardening is another requirement, as these holes are to be threaded, and usually there are no coolant through capabilities. OSG's solution to these challenges is adding an R-gash to an AD drill, which is a high-performance carbide drill. This R-gash decreases the thrust force generated by the drill and aids in chip formation. This, along with the Aegis coating on OSG's A drills, prevents work hardening and increases tool life. Another drilling challenge is a burr left on the exit of the drilled hole. To eliminate this, a chamfer can be added on the shoulder of the drill. For the tapping operations, OSG supplies a special tap, a WXL CPM POT. This tap has a WXL coating for lubricity and wear resistance, and 4 to 5 flutes depending on the size of the tap. Sizes are made based on the specific hub application needs. The main challenge with the tapping operation of hubs is that tool life for the taps is much shorter than that of the drills, around 10 times shorter. OSG's solution is a special WXL CPM POT, which has an increased number of flutes, as well as a WXL coating and CPM powdered metal substrate to increase overall tool life. Here, we can see a comparison of the OSG drill versus a competitor. In this test of 13.7mm drills at these parameters, the OSG drill has a 60% increase in tool life over the competitor drill. For tapping, we can see a comparison of the OSG tap versus a competitor. In this test of M10 by 1.25 taps at 65 SFM, the OSG tap has a 30% increase in tool life over the competitor tap. Another way to improve tapping tool life in hub applications is to use OSG's SynchroMaster tap holder. This features a metal flexure mechanism and a one-part construction for longer holder tool life with ultra-small compensation. The SynchroMaster tap holder solves issues when the synchronous cycle is not perfect, which can lead to a tap rotation error, a tap retraction error, or a pitch error of taps, which would all cause a sudden breakage and result in unstable tool life. In the picture, it can be seen that there is increased wear on the tap caused by overcutting due to unstable threading. With the SynchroMaster tap holder, the feed will always be synchronized with the tap rotation, which will prevent such errors and increase both tool life and tool life consistency. With a normal holder, the machine takes some time to reach the 80 to 100 SFM required for this through-hole tapping operation for the hub. In this time, the tap could already contact the material, which would ultimately result in a decrease in overall tool life. The SynchroMaster will ensure that the tap is at the desired speed throughout the entire operation from start to finish. This is why the SynchroMaster tap holder will increase the tool life of the tap. Thank you for watching OSG's solution for electric vehicles.